Welcome everyone. Let's begin our lesson for today by going over our learning goals and success criteria. First, what are we learning? We're learning how to understand the concept of closure on finite sets. We're learning how to use tables and examples to determine if a set is closed. We're learning how to recognize that division by zero is always undefined. We're also learning how to recognize all numbers as being part of the number system. We're learning how to determine which number set within the number system a number belongs, and how to recognize that all numbers can belong to multiple number sets at the same time. How are we learning it? Through the finite set closure notes and the finite set closure assignment, as well as the number system notes and the number system assignment. When can we use the information in this lesson? To perform simple calculations such as a budget by recognizing boundaries of numbers to determine if adding the items in your budget will stay within your income amount. And how to understand how number sets are affected by mathematical operations throughout the remainder of this course. How do we know we learned it? If we get a score of 4 on the finite set closure assignment and 4 on the number system assignment. Now let's take a look at our agenda for today. We'll begin with our learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. Then we'll take time to go over the finite set closure notes, and I'll give you time to complete the assignment on Desmos. After that, we'll go over the number system. I'll go over the notes with you, and you'll complete the assignment on Desmos. At the end of class, we'll go back over our learning goals and success criteria, and you'll fill out your before you go. Your only homework for tonight is to continue working on the Reasoning with Integers study guide and complete any incomplete assignments that you may have.
Let's take a look now at the finite set closure notes. Our notes begin with our learning goals and success criteria. Now, what does finite mean? Finite means a select number of elements. Therefore, a finite set means we can count the number of elements in a set. The opposite of this would be an infinite set, which means there are too many elements to count. Now, an example of what this looks like is this. S equals the set of -1, 0, and 1. Now, what that means is these are the only values in the set, and we can count them. There's 1, 2, 3 elements in the set. So that's a finite set. We can say that the set is exactly these numbers here. Notice there are exactly 3 elements in the set. Now, closure definition. What does closure mean? Closure under an operation means a set is considered to be closed if when that operation is performed on any 2 elements within the set, the result is also in the set. Okay, note that this must be true for all elements in the set. If there is even one case where the result falls outside the set, then it is considered to be not closed. Okay, so let's take a look at what this means. So here's an example. We have the set of -1, 0, and 1, and want to know, is it closed under addition? So what that means is I'm going to take each of these elements, so like -1 and 1, and when I add them together, I get 0, which is in the set. So that means that the set might be closed. If for some reason, though, I end up adding 2 numbers together, and the result is outside the set. So let's say I add something together and I get 6. Well, 6 is not in the set, so therefore it is not closed. So an example of what would make the set closed would be -1 plus 1 equals 0. Because 0 is in the set, it looks like it might be closed. Now, is there an example we can come up with that makes it out of the set? Well, if we add 1 plus 1, because we do need to include it plus itself, so 1 plus 1 equals 2. Well, 2 is not in the set, therefore the set is not closed. And again, if there's even one example of this, so it doesn't matter that this part ended up inside the set. Because this one example is out of the set, then the whole set is not closed. So how do we account for all the possibilities? So we're going to create a table designed to combine all the possibilities. So we have our table here, like this, and then we're going to add up each of the values. So like here we have -1 plus -1, which is -2. Then we have -1 plus 0, which is -1. We have -1 plus 1, which is 0. Then 0 plus negative 1, which is negative 1. And 0 plus 0, which is 0. 0 plus 1 is 1. Then 1 plus negative 1 is 0. 1 plus 0 is 1. And 1 plus 1 is 2. And we can see that we have two examples that are not in the set. These two here, negative 2 and positive 2. Therefore, the set is not closed. And whenever we say that a set is not closed, we need to say why. The reason why the set is not closed is because of 1 plus 1 and negative 1 plus negative 1. Now, whenever we are checking closure by 0, a set is never closed as long as the set includes 0. It's because if I divide anything by 0, the result is undefined. So therefore, anytime 0 is included in the set cannot be closed under division. There's a video here that shows you how to check closure for finite sets, so you can go ahead and watch that as well. Let's talk now about how we can check finite sets for closure. So all I did was create a table using Google Docs. So I created a 4x4 table, and then I just filled in the numbers of negative 1, 0, and 1, and negative 1, 0, and 1. And we could put any numbers in here to check for closure, whatever the set requires. And what we're going to do is we're going to take a look at if this is closed under addition. So the way we do this is we're going to take each of these numbers here along the top and add them to each of the numbers along the side. So this box here would be negative 1 plus negative 1. So negative 1 plus negative 1 we know is negative 2. Negative 1 plus 0 is negative 1. Negative 1 plus 1 is 0. And then 0 plus negative 1 is negative 1. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus negative 1 is 0. 1 plus 0 is 1. And 1 plus 1 is 2. So once we do that, we can see that we have two numbers here, this one and this one, that are not in the set. So therefore, we would say that this set is not closed. And we can do this with any numbers, or we can do it with any operation. So this could be multiplication. We can still do it with that. So it would just be negative 1 times negative 1, and 0 times 0, and so on. So we could check our finite sets using these tables. Let's talk now about how to sign in to Desmos to complete your work. So what we're going to do is you're going to click on the link to go to the assignment, and it should take you to a page that looks kind of like this. And right here where it says sign in with Google, we're going to click there. And it's going to pop up with our email accounts. You're going to click on your school email account, and it should already have you logged in because you should have already been logged in using Google Classroom. From there, I'm just going to click start the activity, and it will take me into the assignment and allow me to begin. So that's how you will log in to Desmos using Google. Let's talk now about how to complete the finite set closure assignment. So if you look at the top of the page, we have our learning goals and success criteria here. If we scroll down, there's a link here to go to the Desmos assignment. So we're going to go ahead and click on that. And we have our assignment here. We're going to go ahead and click to start the activity. First thing we see is our learning goals and success criteria. We're going to go ahead and click next. And it says decide whether the set S equals 1, 0, 1 is closed under subtraction. So I have a table here, and what we're going to do is we're going to subtract each of these. So negative 1 minus negative 1 is 0. Negative 1 minus 0 is negative 1. And negative 1 minus 1 is negative 2. And then we're going to fill this in. 0 minus 1, minus negative 1 is 1. 0 minus 0 is 0. And 0 minus 1 is negative 1. And then 1 minus negative 1 is 2. 1 minus 0 is 1. And 1 minus 1 is 0. So, as we can see here, most of them fall into the category of the set that we looked at, but these ones don't. So this is not closed because and we're going to go ahead and we click this to type math. We could say -1 minus 1 is equal to -2. So -2 is outside the set. Then we'll move on to the next one. We'll do this again. We'll fill in the table. Now we're doing division. So -1 divided by -1 is 1. -1 divided by 0 is undefined. And so on. So we'll fill the table in, and then we would say this is not closed because, and we'll go ahead and use the math, -1 divided by 0 equals undefined. And then we'll go ahead and fill in each of these. So we'll fill in the tables and decide whether the sets are closed or not. At the end, it gives a question. If 2 was added to the set, would it be closed under addition? And then the last question is there any number that we could add that would close it under addition? So that's what you'll be doing for this assignment. When you're done, you'll go back to your Google form, click Next, and then fill out your before you go.